All right, welcome back. So, in the last video, we were talking about standard deviation and how that can affect the overall spread of our distribution of our data, right? But there's a few other characteristics of these curves that I sort of want to go over that I think are very important and sort of lost, I think, oftentimes in statistics. If you've taken stats before in high school or in college or wherever, oftentimes this is an idea that gets lost. But I think it's very important to go over just to make sure that we are all on the same page here. So, in statistics, we often deal with this idea of probability. And for some reason, people love teaching probability as, like a coin flip. So if I were to flip a coin 100 times, how often, or what's the probability of me getting 50 heads all in a row? Who cares? Who cares? I don't. That's not statistics, right? There's so much more to be said about probability than, that example leads on. So I'm going to totally skip all of that because I think that idea is kind of pointless. And I'm just going to jump into how we actually use probability and how we can apply it to real life. Now, let me draw something. Let me draw a distribution. And it just so happens that I'll draw the normal distribution. Okay? And it could be any distribution. What we're about to talk about applies to any distribution, or at least most distributions. But I'll stick with the normal because that's what we're used to. It's the most frequently occurring anyway. So we know that we have this idea of the measure of center, which is right here, just right down the middle, and we've been using mu to denote that measure of center, and that's just the mean, right? That's just the mean. But we also know that this halfway mark that I just drew is also the median, right? And that median marks off the 50th percentile, right? So let me do it in this color. 50% of the data lie above that black dotted line and lie below, let me do that better, lie below the black dotted line, okay? And let's say somebody comes up to you and they ask, well, what's the probability of me getting something, of me selecting, let's say, some new data point from the population that this came from, okay? What's the probability of me selecting something that is either mu or less? Okay, so either the value mu or less than that, right? So pretty much all the values below mu. Okay, easy enough, right? Easy enough, or at least I'll show you that it's easy enough. So it turns out that, well, we know that this distribution is effectively just measuring where a bunch of data points lie, and let me erase this too. We know that a lot of the data points lie right here, right in this chunk, right? Because this is what the curve is telling us, that a bunch of the data points are, we can just kind of make this up, right here and right here. This is where a bunch of them lie, right? And then as you go further out, it is less likely, that you'll get something way out here. There are less data points out there. They're still there, but there's just less of them. Most of that chunk is right here, okay? So then we'll go back to the question, what's the probability of me grabbing mu and below, all the values below? Well, it turns out that if I were to find this area underneath the curve, it looks like this, right? Turns out that area, whatever that area equals, is our probability of selecting any value from way down here, so I'll just put an X, all the way up to our mu. That's the probability. And we know that since this black dotted line marks off 50% of the data, that means that we can assume that this shaded area makes up the other 50% of the data. So our probability of selecting selecting some value that is less than mu is 50%. percent. Now, oftentimes, let me erase the percent here because we like to express probabilities as decimal points, or as a decimal rather. So instead of that percentage, we'll just say 0.50, right? 0.50. Okay, and the shorthand here, instead of writing prob, we'll just put p. Easy enough, right? Easy enough. And the same is said for the other side too. Since we know that this distribution is symmetric, we know that if we were to instead find what's the probability, and let me see how well I can erase this. Not well. What's the probability of selecting a value from this distribution, or from wherever it came from? What's the probability of selecting it on this side, right? Something greater than the mean. Well, it's going to be 50% again. Okay, so we just need to find that area, and then that's that. Okay, now we'll come back to this idea and use it a lot more. We'll use it way more, because we can also apply this idea of percentiles to this. And let me sort of go on to the next slide here. We've worked with percentiles just a little bit, but a percentile just represents where your position is in comparison to everyone else, right? So if you say, all right, I'm in the 50th percentile, since I've got it written up here, I'll just use that. Since we're in the 50th percentile, I'm gonna keep that. Sorry, that's important. I'm in the 50th percentile. That means that I'm right here, or right where this dotted line is, and then everyone else is below me, or at least the other 50% of people are below me. Okay. If we were to draw something maybe like right here, this would maybe be about the 95th percentile. That means that I am better than, or whatever. I'm better than 95% of the people. Okay. Now, I'm going to pause the video, just so we can kind of separate these ideas. So real quick, just as a sort of recap here, because this is an important concept. This is an important idea. Is that if we were to shade any of the area underneath here, underneath the curve, that just represents a probability. It also represents wherever that shaded area cutoff point is, that represents a percentile too. So if I wanted to, actually I'll just leave all this, I'll do it in this green color. Well, let's say that this is the 95th percentile, right? Then that means that this whole area underneath here, I have a 95% chance of selecting something, whatever we're measuring. I have a 95% chance that it'll fall somewhere in the shaded area. Okay, and that means that the reciprocal is true too. That since this makes up 95% of the data, right, the shaded area that I've got here, that means that the other area that is not shaded makes up the other 5%. And the fun thing about this, if fun is the right word, is that, and I've got it written over here too, the total area underneath any curve is 1, okay, or 100%, and I'll write that too, 100%. So I mentioned earlier that with these curves here, we are measuring a frequency of something, right? We're measuring a frequency, and that can be, we're used to seeing when we're making the boxes that represent some kind of count, right? But in this case, it's the same idea. We're just on this idea of a percentage rather than an absolute count, and that's fine. Okay, so it's the same idea. We're just working with percentages instead of absolutes. Okay, so I'm going to pause the video now, and we'll move on to the next thing shortly.